Okay, YouTube, in this video we're going to explore how we evaluate nth roots to get a decimal on a calculator. So when we use a calculator to approximate an nth root, basically what I'm going to recommend here is we want to rewrite the nth root in rational exponent form. And the reason why is because you're going to be able to input that into your calculator, and your calculator just do the root for you without having to type it into this messy radical notation here. So for instance, this says here, evaluate the expression using a calculator, round your answer to 2 decimal places. I'll keep track of that there. But basically, let's take a look at our calculator here. If I wanted to find 6 to the 2/5 power, we're going to type in exactly like that, except for we're going to say 6 to the power of. So we use our power of key or caret key. And then we're going to put in parentheses 2 divided by 5. So 2 divided by 5 would be our 2/5 there. We're raising 6 to this power. What we end up with is about 2.05-ish. So first things first, I'm going to write approximately 2.05. But second, I just want to comment on really quickly here. We say 6 is our base, but we're really squaring this and taking the 5th root of this. So we're really asking, what number could I take times itself 5 times to get 36 in here? And it must be about 2.05. And just to check that out here, if I took about 2.05-ish to the power of 5, we would get about 36, which is this 6 squared on the inside here. So this is really what we are evaluating for. So this 64 to the negative 2/3. My calculator, our calculators, will even do this. We say 64 to the power of, in parentheses, negative 2 divided by 3, in parentheses, end up with about 0.063. So approximately 0.63. And investigating this one a little bit further, what I see is this. Well, first of all, we would move our next negative exponent here. So we would get 1 over 64 to the positive 2/3. And if I were evaluating this by hand, then I would have said this is 1 over, and we'll do the root here first if possible, 64 to the 1/3. We'll do the root first, and then we'll square it. And I know that the cube root of 64 is 4. So I really get this. I get 1 over 4 squared, which is 1/16, which is the value that we did get on our calculator, but then we did round it. So rewriting this in rational exponent notation, I would say this is 16 to the 5th power, 4th root. And so we'll just get our calculators rocking here. We say 16 to the power of 5 divided by 4. Enter. Okay, so we get 32 here, so 32. And then we would say that this is a plus or minus, as a matter of fact, because of our even root here that we took. And then on this last one here, we have the cube root of negative 30 squared. So another way to write this would be that we have this. We have the cube root of negative 30 squared. So negative 30 to the 2/3, which is also negative 30 to the 1/3 squared. But we're going to use our calculator anyway. So when we type this one in, the important thing here is that we put the negative 30 in parentheses. We want to take the negative with this 30 to the 2/3 power. So I'm going to use parentheses here. We say negative 30 to the power of, in parentheses, 2 divided by 3. 2 divided by 3. And I get 9.65-ish. So this comes out to be approximately 9.65-ish. But that's how we can use our calculators to evaluate rational exponent notation. Cheers.